Hello everyone, welcome to today's session on multivariate data analysis. This is Anita, Assistant Professor from Department of Artificial Intelligence and Data Science from Ramco Institute of Technology. In this lecture, we are going to discuss one of the fundamental concepts in data analysis. So let's begin with the course outline. Before we start the concept, let's have a quick look at what we are going to cover in today's lecture. First, we will understand how data analysis is carried out based on the number of variables being studied. This is the basic idea behind univariate, bivariate, and multivariate analysis. Next, we will learn each of these techniques in detail. By the end of this session, you should be able to identify whether a given problem requires univariate, bivariate, or multivariate analysis and understand the purpose of each approach. Now that we have seen the course outline, let's move on to the first concept, understanding data analysis based on the number of variables studied. So let's go on to the overview of the three techniques. The first type is univariate analysis. As the name suggests, uni means one. Here, we analyze only a single variable without considering any other variable. Their objective is to describe and summarize that one single variable. So the next one is bivariate analysis. In this case, two variables are analyzed together. The main objective is to determine whether there is a relationship or association between those two relationships. Okay, so the third type is multivariate analysis. Here, three or more variables are analyzed. Since many real world problems involve multiple factors, multivariate analysis helps us understand these complex relationships and support better decision makings. So the key difference among these techniques lies in the number of variables being analyzed. As mentioned earlier, univariate analysis deals with only one variable. It is the simplest form of statistical analysis because our focus is only on the studying a single characteristics at a time. Okay, so unlike other analysis, univariate analysis does not examine any relationship or dependencies between variable. So instead, it helps us understand the distribution and the behavior of that one variable. So for example, suppose we collect the marks of 100 students in a mathematical examination. If our objectives is only to summarize these marks, such as finding the average mark, highest marks, or how widely the marks are spread, and then we use univariate analysis. So now let us understand univariate analysis with a simple example. Now suppose we have collected the height of 7 students. Here the variable under study is height measured in centimeters. Okay, so the data values are mentioned here with the centimeters. So now notice that we are studying only one characteristics, which is the height of the students. We are not considering any other information like weight or age or marks. We are just considering only one, that is height. Okay, so since only one variable is involved, this is an example of univariate analysis. Using this data, we can answer the questions like what is the average weight of the student, what is the minimum and maximum weight, or how much variation involved in this height differentiations. To answer these questions, we can calculate measures like mean, median, mode, or even range, variance, or even standard deviations also involved. So therefore, this is a classic example of univariate analysis. So now let us understand how univariate analysis can be represented graphically. Okay. So the figure shown here is a frequency distribution of a single variable. On the horizontal axis, we have different values. From this graph, we can quickly identify whether most of the observations are concentrated or not. For example, in this figure, see the middle bars are taller than the other. So it indicates the observations are clustered around it. So the graphs such as the histogram, bar graphs, and box plots are commonly used in univariate analysis because they help us understand the distribution of single variable in a visualized manner. So we will move on to the bivariate analysis where we study the relationship between two variables. Now let's move on to bivariate analysis. Unlike univariate analysis where we study only one variable, bivariate analysis involves two variables. It measures for both or each observations. So the main objectives of the bivariate analysis is to determine whether a relationship or association exists between those two variables. For example, we may want to study whether the number of horses a student studies affects their examination mark. So For that, we are using this analysis techniques. So in both cases, two variables are involved, and we are interested in understanding how one variable affects the other. So to measure the strength and direction of this relationship, we commonly use statistical measures such as correlation coefficients and covariance. So, to visualize the relationship between two variables, we commonly use scatter plots where each point represents one observation. For category variables, cross tabulations also. So, let us understand bivariate analysis with a simple example. In this table, we have two variables, temperature and another one is a ice cream sales. For each temperature value, we have a corresponding sales value. For example, at 20 degrees Celsius, the sales are 2000 rupees. So the next one is at 25 degrees Celsius, the sales increases to 2500 rupees. So finally, see at 35 degrees Celsius, the sales reach 5000 rupees. So if you observe these values carefully, we can see a clear pattern. As the temperature increases, the ice cream sales also increases. This indicates the positive relationship between those two variables. In other words, they also involve in the same directions. So if we calculate the correlation coefficient, we would obtain a positive value. So it is a confirmative positive association. So this example clearly demonstrates that purpose of bivariate analysis. So let's understand multivariate analysis. So multivariate analysis is used when three or more variables are measured for a single observation. The main objectives is to understand the combined relationship among those multiple variables. And for example, suppose we want to predict a student's academic performance, the outcome may depend on several factors like study hours, their attendance percentage, their previous academic performance, and the participations in those extracurricular activities. So, since multiple variables involved in the results, this is the main approach that we used for multiple variables finding. In multivariate analysis, we also study the joint effect, which involve one or more outcome variables. This helps us understand how different factors work together to get the final results. So, the several advanced statistical techniques are also used in this multivariate analysis. Now, let us understand multivariate analysis with a suitable practical example. Okay, in this example, we are analyzing three variables. One is an advertisement type, next is gender, and next one is click rate. Notice that each observation contains variables, and instead of studying each variable independently, our objective is to understand how they interact with one another. For example, consider the first observation. The advertisement shown is AD1. So the ad 1, the user's gender is male and the corresponding click rate is 80. So similarly, the observation contain different combinations of advertisement type, gender and the click rate. Now suppose a company wants to identify which advertisement platform is better, whether the user's gender is male or female, or answer these questions, we have to require all three variables together. So here advertisement type, gender and the click rate also act as an influencing factors. By analyzing these variables, we can identify patterns such as which advertisement receives the highest click rate and which combination of advertisement type and the gender produces the best response. So this is the essence of multiple variable contains the multivariate analysis. It helps understand the combined effects of multiple variables, so leading to much more accurate predictions. So in the next session, we will compare these techniques side by side to understand their differences and the appropriate applications. Now compare those three techniques. The first one is univariate analysis. It involves only one variable, and the bivariate involves two variables, and the multivariate involves three or more variables. The next is the purpose of the analysis. And the first univariate involves describing and summarizing a single variable, and the bivariate involves the relationship between two variables, and the multivariate involves the combination between the multiple variables. So, if we look at the relationship being studied, univariate does not investigate the relationship because it involves only one variable. So, the bivariate involves two variables relationship, and the multivariate involves several variables. So, the commonly used techniques are for three techniques are, and the first one is univariate analysis. We uses the mean median mode for measuring And the bivariate we use as the correlation coefficient and covariance, and like simple linear regressions formulas for analyzing this. And the next one is to identify multiple variable we use as the multiple regression, principal common analysis, factor analysis, cluster analysis, and also manova. And the visualization methods are also vary. The univariate analysis uses the histogram, box plots like that for visualization, and the bivariate uses scatter plots, regression lines. Those are used for the relationship comparisons. And the next one is multivariate analysis. It uses the heat maps, pair plots like that. So the next slide is choosing the right technique. After understanding the different multivariate techniques, the next one is to choose the appropriate technique. Okay. So if the goal is to predict a continuous value, we use the multiple regression. So if you want to reduce the number of values, we use the principal component analysis. So to group a similar observation, we use the cluster analysis. To identify a hidden factors among those variables, we use the factor analysis. And when comparing the multiple groups based on several dependent variables, we use the MANOVA. Finally, if the objective is to classify observations into a predefined group, we use the discriminant analysis. So the choice of techniques always depends on the problem we want to solve. So multiple regression, it is used to predict a continuous dependent variable using a two or more independent variables. It also helps us understand the effects of each independent variable while keeping the other ones as a constant. Okay. So for example, we can see employee's salary can be predicted using a factor such as experience, his education, or his training horse. So here salary is the dependent variable, while the education and their experience or the training horse are the independent variables. So the graph shows the relationship between the multiple independent variable and the one dependent variable. Next one is the principal component analysis. Now let us discuss principal component analysis. It is a dimensionality reduction technique. So it converts a large number of correlated variables into a smaller number of principal components. So while preserving the important information, we are using this principal component analysis. For example, if a customer survey contains 20 variables, and PCA can reduce them to three principal components, making the data easier to analyze. So this figure shows how high dimensionality data is transformed into a principal component. Okay, and here it is widely used in machine learning and data analysis for simplifying a large number of data into a smaller one. And the next slide is cluster analysis. So the cluster analysis is an unsupervised learning technique. So it is used for the grouping of similar observations into a cluster. Their main objective is to ensure that the objectives within the same clusters are more similar to each other. So a common example is that a customer segmentation where customers are grouped based on their purchasing behavior. It can help design a targeted marketing strategies. Okay, so this figure shows how similar observations are grouped into a distinct clusters. Slide factor analysis. So this technique is used to identify hidden or underlying factors from a large number of unrelated or related variables. So instead of analyzing every variable separately, it groups a similar variable into a meaningful factors. For example, a customer survey, many questions can be combined into a factor such as trust, service, quality, and satisfactions. So this example is the data analysis and makes the interpretations much easier. So the next one is a MANOVA. The next technique is MANOVA, which stands for multivariate analysis. For variance, it is used for the comparison of two or more groups. So it is based on the multiple dependent variables. At the same time, unlike ANOVA, which analyzes only one outcome, MANOVA considers several outcomes together. For example, we can compare different teaching methods using a student's mathematics or science or English scores. Okay, so likewise, we measures this MANOVA techniques. So the next one is a discriminant analysis. Finally, let's look at discriminant analysis. This is a classification technique. It predicts the undefined or a predefined group an observation belongs to. It identifies the variables that best distinguish between those different groups. For example, banks can use a discriminant analysis to classify loan applicants as it is approved or rejected based on the factors like their income and the credit score that they have scored, and it is widely used for the decision making purposes. To conclude, we have learned the three levels of data analysis: univariate, bivariate, and multivariate. As the number of variable increases, the analysis become more powerful. The session concluded here. Thank you for listening. Thank you.